In class today, we went through the help sheet and the importance of doing it right. Read those directions carefully and be sure you start with title, name, date, and period in the top right corner, then do your help sheet. Oral reports are no longer, but doing the homework is what you need if you're going to do well on the test. I want you to check announcements just to orient yourself to the remainder of the semester. And these three screens that follow, these are things that you would do very, very well to have on your help sheet. Okay, the stuff, either this little chart down here and or this chart, whichever you prefer, to be able to do your anti-logs and logarithms when you're in the test. And for Le Chatelier, this is golden. You just want to be sure that you have that and have practiced some of those problems. Here, I would copy everything that's on this sheet. And the link for it is on the homework page for April 25th. When you look at this page, you're seeing things from the acid-base, or acids, ions and acids to memorize. And I've circled the things that you would do well to have on your help sheet. And then we're going to be talking about the number out front today and the log, and we're going to be doing a lot of review looking at homework problems over the last few days. There's a lot of stuff on the whiteboard this week that you would do well to look at in your, after you see this, that you would want to look at online. And so you want to check that out. First thing I wanted to do was review this. If you look at this sequence, we've looked at this before. This sequence takes you from 1.0 times 10 to the minus 12 on down to 1.1, 2, 3, 4, 5, 6, 7, 8, 9, and then down to not this, not at all, this, okay? This is 10 now times 10 to the minus 12. Why does it look like this? Because we have to be in scientific notation when we do concentrations. If you're not in scientific notation, you won't be able to find logs or anti-logs. They won't work. Okay, because this exponent is critical for your starting place. So just know that this makes this number increase in size. The power of 10 going down, the negative power of 10 going down, makes it obvious, if you think about it, that this number is much bigger than this number. So let's go on, and with that in mind, let's look at some of the things that we've gone through. And we have been doing finding the pH and pOH given a concentration. And so if I put the curtain up here so that we can focus on one thing at a time. If you're given a if you're given a hydroxide ion concentration of 3.9 times 10 to the minus 14, you can get the pH. And we went through this method yesterday, and I did a video on it yesterday, and I'm just really quick going through it. I'm not going to try to explain it in detail. But this log over here, this minus log of 3.9, is coming from the number out front in the concentration of the hydroxide ion. The weird thing about logs, and this is truly weird, 3.9 times 10 to the minus 14, after we take the log of each of those, we're going to add, we're not going to multiply. We actually add. So I've got minus 0.4 as the log of 3.9. When you look on those little tables, like I showed back here, here we go, these guys, okay? When you look on these tables, the left-hand column is a number. It is not a log. The log is on the right. What we're going to do later on this video and later in this period, we are going to take the log and change it back to a number. So instead of going left to right to take the log, anti-log takes us from right to left. And we'll get into that as we get into those problems. But first of all, this is how we solve these problems. Taking the minus log of 10 to the minus 14 is like falling off a log. Oh, it's like falling off a log. Yes, it is. So, because this is so easy to do. You don't need a log table or anything. You just look at the exponent, change the sign, and you've got your number. And that's the logarithm of 10 to the minus 14. So when we add those guys up, because this is a minus log and there's no minus exponent anywhere to deal with, all we have to do is make it a negative number after we log it, which is taking the number on the left. And when I take the number on the left, I need to get a chart here. Yes, there it is. When I take the number on the left, I have 3 and I have 4, but I don't have 3.9. So when I look at the 4, I'm going to call that, we're logging that number. And if we go a little bit smaller, we would have 3.9. Oh, yeah, there we go. 3.9, we would be below 60 and higher than 48. So I probably didn't do this the way I should have. I think I was using the other simplifier, more simplified chart. But either way, we're going to come out fine with this number. So 0.4. And now we take this logarithm and subtract from this because it's a negative. So we subtract that out and we get 13.6. That number is our hydroxide ion concentration. Okay? And I have another example down here. You would do well to stop the video right now. After you write down notes from this part, what we did up here, then try and solve this without looking at anything but your notes. And you'll see if you really have learned what to do here. Question? 3.9? No reason to round it. I essentially rounded it, but believe me, this number doesn't have to be that accurate. That's why I've given you such a very simplified chart. The one that goes on the bottom of the chart that we just went to on the video here. John? Never mind. Okay, never mind. All right, so work this out. Stop the recording, work it out, and then come back. How did you do? Is this what you got? Okay, if you did, you really understood, and you're good to go on this part of logarithming. Oh, I just coined a new word. Okay, logarithming. Yes. Okay, so homework answers. We got a lot of stuff. If you don't know that hydrogen ion concentration, when we take the log of it, the minus log, is going to give us pH. Hydroxide ion will give us pOH, but the calculation is identical. It's just that in one place we're starting out with hydrogen and the other place hydroxide. These guys you need to be able to do. And these two formulae right here, you want to have these guys. You will use those during the quiz. Now, I'm looking at homework for page 609, which was a few days ago. Oops, I didn't want to add a page. What I wanted to do was split it, and what I did is I worked it out across 2 pages. You can look at this on my whiteboard file, or you can just satisfy yourself with looking at it here, whatever. See if you understand. Looking at so many problems that are so very similar in a row will help you get a feeling for, hey, I think I understand how this all works because I see the same thing from line to line. And once you get the hang of that, you're going to be doing great on the quiz. Let's get this back to full screen. And now here's another example of doing the log, minus log. Minus log of 1.5 is equal to this 0.3. And it's a negative number because it's a minus log. The exponent of 10 is 4, so we change the sign because the log is negative. It's a negative log, and we just get 4. Subtract them out, there's your pH. Just that easy. Take you to pOH, you subtract that from 14, and you got your pOH. Another easy one. The hydroxide ion concentration, if we're given that, it's just like this problem, only we're talking about hydroxide ions. So the -8 becomes an 8 because we're taking the minus log of it, just like we did up here. And the minus log of 7.9, okay, if I look at 7, the 7.9 is between the 7 and the 8 on my chart in the number column. And you look over there at the logs, and that's where we get the 7.9. And actually, I'm probably a little bit off on that because the number of 7.9 is actually between 3 and 4. Oh, no, it's between 7.9 is between 8.5 and 0.90. So this probably should be raised a little bit. But again, it's not going to matter that much because on a test, you'll be able to find the multiple choice answer that matches with no trouble at all. So our pOH on this guy is going to be the minus log of this subtracted from the minus log of this, and we get 7.1. And let's move on. Check these problems out. Make sure you're doing them right. We didn't check these in class. So take the time to look at them and make sure that you understand what's going on. If you can get these from the prompts in the book, you are in good shape. So you can check if you did your homework, whether or not you did it right. No better time to check that out. Okay, in 87 on page 631, here's all your answers that you can look at. Take whatever time you need to look through it and make sure you understand it. Page 612 and 631, that's all here. Okay, it's all there for you. Number 87, a bird of a different feather. Okay, we haven't done this kind of thing before. So let's look at it carefully. And let's get the shade up so we go one piece at a time. Okay, this is our given and the find. This is really pretty slick because it hails back to, where is it? Just a couple of pages ago. I gave the guy that you're going to use to solve this. No, it's right about, there we go. Hydrogen ion concentration times the hydroxide ion concentration is equal to 10 to the minus 14. Now watch how I do it when I plug this guy in. Oops, here we go. So K sub W, there it is. I didn't need to go hunting for it. It was right here. So K sub W, this is just a K equilibrium. All right, just a K equilibrium. And so that K equilibrium is right here. And you're going to plug in this number, which is the hydroxide ion concentration. And that goes right here. Okay, see where I am? The hydrogen ion concentration stays because that's our unknown. And here is what these two guys multiplied by each other always have to be. So let's go down here and see how we solve. I think most of you know how to do this. Divide this on both sides. See what I did? Right here. Here it is again, again, and again. This side, it'll cancel itself out, and that leaves this alone on the other side. Or this is alone on this side, and all we have is numbers over here. Now we can easily solve. Now we're going to divide both sides by the hydrogen ion concentration. Okay? The hydrogen ion concentration that was the hydroxide, wasn't it? That was the hydroxide. Okay, so I got that straightened out. This guy is the hydrogen ion concentration, and this guy is the hydroxide ion concentration. So when we divided both sides, we're going to be good. So next, when we divide this, I always do this as factors. And so the 1 is divided by 1.3 to be 0.77. And the 10 to the minus 14 is divided by 10 to the minus 2 to give you 10 to the minus 12. Then we have to take our decimal and move it over, which makes the power of 10 10 to the minus 13 in the final answer. And then the 7.7 out front. And that's the molarity of the hydrogen ion. And that's it for that problem. We'll leave that uncovered so it goes up on the web, and it will be, this whole file goes up on the web and can be seen. Here's your answers for 88 and 89. I don't think there's anything funny here that we need to cover. Just make sure that you're up to and understand what we've done in all of these cases. Next, 91. That was a real bird of a different feather. And so what we want to do is just take a look at the prelims. Here's all the stuff that we're given. So take whatever time you need to take a look at that and make sure you understand all of that stuff that's given. To make this problem work, you have to get this balanced equation. It won't work without it. This should look familiar to you because this is an acid ionization. It's the first acid ionization for phosphoric acid. And so as we do this, we want to mark it up so we know the acid, the C base, the base, and the C acid. If you don't know how to do that, you need to spend some time with this, make sure you understand that. Next, the pH of 2.3, we are going to have to anti-log. That's something you've never done before. I'm going to go through it a little bit on the fast side for the first shot. Then I'm going to take you to a screen in just a moment where we'll do this in more detail. And I will do that on a second video. So here we go. The anti-log of 2.3. To do that, you round this number. Okay, so the anti-log of 2.3 is going to be rounded up. We're going to round up this minus log of 2.3, the anti-log of 2.3. To get that, we're going to round this up to the next whole number. That's why this is 3. That becomes your power of 10. Here, this guy is going to be the number that we started with, the pH. Both of these are logs. That's why we can do this math. If one was a log and one was a concentration, this would not work. It would be like multiplying oranges by apples. How do you do that? You can't. So when I get this number, this is a log, and that is going to be the number out front when I take the anti-log. But the anti-log that I'm going to take is of 0.7. When I took the anti-log of 3.0, I just make it the power of 10. Okay? So the 3.0 becomes the power of 10 down here, and when you find the 0.7 in the logarithm column, and you go back 0.7, I actually have a 0.7 in my 1 to 10 chart, and that just goes to a 5. Okay? The number in the left-hand column is a 5 when you look up the 0.7. So the 0.7 is the log, 5 is the anti-log. So you put these anti-logs together like this, and you're done. That's the number you're after. Now I'm going to give you another practice problem. Oh no, that's just part of a problem. Oh yeah, I forgot. So we got the hydrogen ion concentration. That is the same thing as the hydronium ion concentration. And the hydronium ion concentration for a strong acid, which is what H3PO4 is, the strong acid is going to have the same concentration as the hydronium ion. There they are, side by side. And this is the H2PO4 that is up here, not the H3PO4. Now, think about what that means. In the acid ionization, this guy comes apart. What gets formed? We're going to get one of these, the hydronium ion, and one of these. So if I'm told that the pH is 2.3, I know that my hydrogen ion concentration is 2.3. And that when I do the antilog to get the concentrations, I'm going to be able to get that back to 5 times 10 to the minus 3, and that fills in both the H2PO4, which is the C base, as well as the C acid. And that's what we have on the right side. Those are products. The reactant is down here. That's the H3PO4, and its concentration is 8.6 times 10 to the minus 3. So this is purely plug and play. And these two guys over here, I've taken the 5 and this 5 and this 8.6 and separated them out and run the math on them to get my 2.9. And then the rest of it is the 10 to the minus 3 times 10 to the minus 3 divided by 10 to the minus 3. See, they come from here, here, and here. When I run those numbers, I get 10 to the minus 3 here. So 2.9 times 10 to the minus 3. This video is way long enough. I'm going to stop, and then I'm going to do more on the next video is going to be all anti-logging. So I hope this is helpful for you. Those who need the review, I hope you found this helpful. And see you at the quiz tomorrow.